Hello everyone, today we are going to discuss the next type of the numerical on the topic of cam and follower, which is based on the oscillating roller follower. So here we have the statement, the following relate to a cam operating an oscillating roller follower. So follower is the oscillating roller in which the follower moves with SHM during lift and returning. Means for both outward stroke and return stroke we have the simple harmonic motion. Then minimum radius of cam is given 25 mm, so RB is equal to 25. Roller radius is given, RR is equal to 10 mm. Length of follower arm, so follower arm length is given. So in case of reciprocating follower, no need to mention this length of follower arm, but here in case of oscillating follower we require this. The next is distance between pivot center and cam axis is given, because we know that in oscillating roller follower we fixed the one end, and the one end where our roller is there, which is in contact with the cam, so that pivot point distance to the center of cam distance is given, so that is equal to 75 mm. So we are considering that pivot point is O2, cam center is O, so O2 is equal to 75 mm. Then angle of ascent is given 120, descent is given 120, angle of twirl is given 120. Now see here, firstly they mention angle of ascent, then they mention angle of descent, and at the end the angle of twirl. Means there is a no dual period between the ascent and descent. Okay. Then angle of follower oscillation is given, that is theta s is equal to 20 degree. So before draw the displacement diagram, let's draw the oscillating follower separately to calculate the stroke length. Okay, so here we have the length of arm. So here we have the length of arm 70 mm. So I have drawn here 70 mm distance, that is equal to 7 centimeter. This is our arm length 70 mm. Now angle of oscillation is given, so from this, let us say this is point O2, that is pivot point as we have considered. Then from this pivot point let's take 20 distance, 20 angle, 20 degree, and draw an arc. Draw a length, and now draw an arc from this point to this line. So this is point O, okay, or we can say that this is O1. Now as you can see, here is the pivot point, this O1, right here there is a roller, and this O1 is the center of roller, and this roller is oscillate with angle 20 degrees. So in this way roller going to oscillate. So we have this construction, and now we need to calculate this length. Okay, now how we can able to calculate this? This is using of theta and r. So we know the formula for that. Stroke length is equal to arc O1 dash, and how we can able to calculate this arc? It is equal to this distance 70, that is r theta. Okay, 70 into 20, but we need to convert this 20 into radian. Right now it is in degree, so 20 degree into pi by 180, so that is equal to 24.43 mm. This is our stroke length. So in this way we need to calculate the stroke length in case of oscillating roller follower. Now let's start to draw the displacement diagram. Let's draw the xy axis. So we know that cam rotated with 360 degrees. So on x-axis we are taking cam angle, on y-axis we are going to take a stroke length. So cam angle total it is 360 degree, so we are going to take a scale 1 centimeter is equal to 20 degree. So total length is 18 centimeter, and vertically our stroke length is 24.43 mm. So it is 1:1 scale. So here we get that much stroke length. Now let's divide this cam angle into outstroke, return and dual. So as we know, outstroke is 120 degree, then there is a return, and then at the end there is a dual. So 120 degree, it is 120 divided by 20, so 666 centimeter. Now the motion is given simple harmonic during outstroke and return stroke. So let's just divide this or draw a simple harmonic semicircle having diameter is equal to stroke length. So here I have simple harmonic semicircle. Now just divide the simple harmonic semicircle into equal even number of part, say 6. So let's just divide it into equal even number of part. Now as we divide this simple harmonic semicircle into 6 parts, so let's divide this outstroke into 6 number of parts, and also return stroke in 6 equal even number of part. Now see, this is our return stroke, because what they says there is angle of ascent, angle of descent, and then there is a dual. So the second is our dual period, sorry, return period, not the dual period. So as we divide this return into 6 part, let's just draw the vertical lines. Similarly, from this outstroke, let's just draw the vertical lines, and now draw the horizontal line from the points on simple harmonic semicircle. Now firstly start from 0, then horizontal line of 1, and here we have the vertical line of 1, horizontal line of 2, and vertical line of 2. Similarly, vertical 3, horizontal 3, vertical 4, horizontal 4, 5, 6 point is here. And similarly for 7 we have this line, and at the end we get the point 12. Now join this point with a smooth curve. This is our displacement diagram of follower RRD motion. Now let's draw the cam profile. So let's start from the base circle radius. So base circle radius is 25. So let's just draw it. Now we have the roller follower. So to tangent the base circle, let's draw the roller follower having RR is 10 mm. So here we have the roller follower, but in previous case our roller follower is the reciprocant, so we have constructed in vertical way. Now this is the oscillating, and we have the pivot point and the arm of roller. So let's first draw the arm of roller, or let's take the distance equal to arm of roller, that is 70 mm in your compass, and mark an arc from this center of roller with distance 70 mm. Now secondly we have the distance between pivot center and cam axis. So here we have the center of cam, let me give the name O, center of a roller is O1, So distance between center of cam and pivot center is given, that is 75 mm. So from the center of cam, let's just draw an arc which cut the previous arc, because previous arc is what? Length of the roller, that is distance from center of roller to the pivot point, and now we have distance from the center of cam to the pivot point. So we cut the previous arc and we get the point O2, which is the pivot point. Okay, now join this pivot point with the cam center using dotted lines. Also the pivot point with the center of roller. This is the length of arm, and let's just put this point as a pivot point. So we get this is the arm, where our roller is oscillate with an angle 20 degree. Now here outstroke, firstly let's draw the prime circle, which is the concentric with the base circle and passing from the center of roller. Okay, so here we have the prime circle. Now in case of this oscillating type of the follower, we need to draw one more circle. That circle is called as pivot circle, having radius equal to distance between the pivot center and cam axis. So we have the pivot circle here. Now let's divide our cam with an angle, given angle. That division start from this length, that is O to O2. O to O2. So from this line we are going to take our first angle, that is outstroke 120 degree. So here is our outstroke 120. Then the next return stroke is again 120 degree. Here is our return stroke, and remaining is the 12. So let's just mark first angle started from this length, because the follower is the oscillating type of the follower. So when cam rotated from base circle, it will be goes up and then comes down. So first angle, outstroke angle, is start from here 120 degree. Then return is dr theta r 120 degree, and remaining is dual period theta d. Okay, that is also 120 degree. Now as we divide the outstroke in displacement diagram, 6 division, so let's divide it in angle with 6 division. Now here is the one very important fact. Now we have the outermost circle is the pure circle, and we have divided this outstroke into 6 equal division. So mark those point 0, 1, 2, 3, 4, 5, 6 on pivot circle. Okay, now we are going to take pivot circle to make 6 equal divisions. Okay, so I have marked 1, 2, 3, 4, 5, 6 point on pivot circle. Now take the distance equal to length of arm in your compass. From point 1, mark a point on prime circle and say that is the point 1 on prime circle. Similarly, from point 2, mark a point 2 on prime circle. As we know, this is the length of arm, and when cam rotated, the position of roller will be changed, so that we just mark the changing positions on prime circle, taking distance equal to length of arm. So this is 4, this is 5, and 6. Okay, now we get 6 equal division on prime circle after taking distance equal to length of arm and putting that or from point on pivot circle, mark 1 2 3 4.5 6 points on prime circle. Okay, now let's just extend this point 1 2 3 4 as an arc, and now on this arc we are going to place this ABCD point. So let's measure this distance in your compass 1 to A, and on the arc which is passing from point 1 from the prime circle, on that arc mark point A. Similarly, take distance equal to 2 to B, and on the arc from point 2 from the prime circle mark point B. Similarly, 3 to C, third arc from point circle, 4 to D, fourth arc from point prime circle, then 5 to E, fifth arc from prime circle, and 6 to F, sixth arc from the prime circle. Give the name ABCDEF. Now draw the curve passing from point O1, that is center of roller, to point ABCDEF. Okay. Similarly, let's divide this return stroke into 6 equal number of parts. So after dividing the return stroke into 6 parts, give the name. So it starts from here 6, 7, 8, 10, 11, and last is the 12, and that division is on pivot circle. Okay, now what is next step? Take distance equal to length of arm in your compass. So from point 6 draw an arc which is cut your prime circle, so we already have that arc. Then from point 7 draw an arc which is cut your prime circle. Do the procedure from point 8, 9, 10, 11, and for 12. Give the name 7, 8, 9, 10, 11, and 12. Now in similar manner, let's just take distance 7 to G from the displacement diagram, and on that arc from the prime circle mark point G, then 8 to H, then on the arc 8 mark point H from point circle, then 9 to I, 10 to J, so here we have the 10 to J, 11 to K, so here we have the point K, and last is on the same circle. Now draw the smooth curve from these points. So this is our pitch circle. Sorry, this is our pitch curve, because that is the curve traced by a trace point or traced by center of roller. Now we need to draw a cam profile, and how we can draw the cam profile in roller follower? From this position of the roller, that is A, B, C, D, draw a roller having radius is equal to our roller follower. So here from point A, B, C, D we have drawn the roller, and now let's draw a curve which is tangent to this roller, and that is our cam profile. Now cam profile is maybe inside the prime circle, but which is tangent to the base circle. So this green is our cam profile and pink is our pitch curve in case of oscillating roller follower. I hope you get the concept. Thank you for watching video.